everyone. I'm Kristi Wallace and with Matt Loewen, and we both work at AVO here in Anchorage. So yeah, we appear to do things in pairs when it comes to data and samples. Thank you, Abby and Cheryl, for that first presentation to really set the stage. And we actually aren't going into a whole lot more detail. This presentation is just to help people better understand how to search for samples, how to obtain them for your research. And so we just kind of have put together some best practices, and we'll work on making that into a document that can be shared so that when you go through this process, it'll be a little bit easier. Okay, should go back. Okay, so yeah, looking at this picture here, we're definitely not talking about the left-hand side, all of the fun field work. We're talking about the right-hand side, looking at boxes, and probably in addition to that, we should have had just a crazy long spreadsheet. Okay, so really all of this starts in the field. So Cheryl talked to us a little bit about some of the modules in GeoDiva, and those are the sample metadata that start out in the field. And so we have standard naming protocols, the type of metadata that we're collecting, and then a very strong requirement to put all of that information into GeoDiva. So there's different incentives to do that. Internally, it means that we can access our own data and look at it. And we also have, supervisors who tell us we have to. So this is good though, it's become a standard. On the right-hand side, there is a Strabo's Tephra. So there's a Tephra module of Strabo that's been built with collaboration with the global Tephra best practices group. So together, globally, we've been trying to do things in a more standardized way across the world in terms of Tephra. So we started collaborating with Strabo. They created Strabo Tephra. And as Abby said, Matt has really taken the lead on collaborating with them so that the data that get dumped out of Strabo in the field are formatted exactly to get ingested into GeoDiva. So it just speeds up the process a little bit. Okay, so I'll stand closer here. So we have these spreadsheets that we fill out as soon as we get back from the field. Now, if you use Strabo Tephra, you don't have to fill out the spreadsheet. It's automatically built for you. You just, press a button. But for those of us who are using field notebooks, we're still going in and filling out this spreadsheet. So we're looking at things like standardized station and sample IDs. So in this case, we have the year. A lot of good metadata is built just into the sample and station ID. So the year 2024, Augustine, so AU for Augustine. In this case, it was a Matt Loewen sample, so ML, and then the station name, which is 002. And this really helps. So we try to make this a standard, and we ask that other people use it as well. You don't have to, but it really certainly helps. And then kind of go through the spreadsheet. We have qualitative information about the location description, the latitude and longitude, and of course the datum is super important. The possible source volcanoes. Now this could change, and sometimes you're in an area where there might be multiple volcanoes that could be the source, and so you can just put that information, because later you can modify this to include the actual source that you come up with through analysis. And then the sample type. This is a pick list, so there's lots and lots of information here, but this is then searchable, so it'd be a good keyword. In this case, they're all tetrapol samples. And then there's the second type of second type of sample ID, which is just kind of further modifies the sample type. And then the detailed description. This is really important. This is what people are really looking for. And then there's a whole bunch of other stuff in there that you might want to add. The data that we're showing here is kind of the minimum that Cheryl requires, or now Abby, for the database, but many of us will also put in other information, including this new stratigraphic information. The database used to just hold samples, and now it's holding all the layer data as well, which is really fabulous. Okay, so then we move it into the lab. So things have been uploaded to GeoDiva, all of our field information. Now we're starting to do all the processing, and we're documenting all of that. It's important to point out for this community that a lot, or maybe most of this information is contained in the Tephra lab and other individuals' spreadsheets, but mostly in the Tephra lab. files and not necessarily in GeoDiva. There isn't a module for everything, but it doesn't mean it doesn't exist. So know to reach out to people, and we do have more information. If samples are published, often some of this information makes it into an appendix or a raw data file, but not always. And of course, some of that means good imaging, and we have the image database, and we try to use that as much as possible, but sometimes we just have hundreds of photos for any, one sample. So that's something that the multimedia database should help with. And then there's the pre-GeoDiva time. So 2022 or 2002 is when GeoDiva started, and Cheryl started, building these modules. And as soon as I think it was 2005 that the module for the field metadata was required, everything since about 2005 is in GeoDiva. People have been following the standard and been adhering to that. But we have samples that are way before this time that are really important, that represent eruptions like Nova Erupta 1912 and many other eruptions. And we have those samples. So our colleagues have sent them to us, whether they were at AVO or they were working in Alaska, but working in another office, whether through academia or through the USGS. Those samples have all been returned to us. And the metadata may not necessarily be fully documented. So here's some examples of an incredible gold mine of information. There's magnetite splits and glass splits, bulk samples, all sorts of things. Lots of text and writing on bags. And then we'll be sent maybe a whole, this is just one example, but many boxes of files. Each one of those represents the metadata for a single sample. They're not connected to that sample quite yet. And then location, that's really important. Often if we want to get into the database so that we can store it, we'll put in a default sample location, and that's usually the summit of the volcano. Not super helpful to people, but at least it's coming from that volcano, and that, yes, we do have access to the maps if someone's willing to sit down and digitize them and connect the sample to the map. So this is just another example of that. So these can be really complicated, but really goldmine of information. Some people have spent the time because of requests, or maybe they were doing their own research to fill in the metadata. But for other data sets, just know that it probably exists, but you might need to help us get it into the system so that it's accessible and searchable by everyone. Okay, so checklists, go figure. I love checklists. Thankfully, Matt does too. So we came up with this checklist just for how to search and obtain samples and data from that are AVO data. So we'll go kind of through these step by step. And then we'll make this available, of course, to people so that if you start looking for samples and you want reminders on how to do it, some best practices, we will have a document to give you. Okay, so Cheryl and Abby both talked about the ability to look up geologic sites. So where have we been? Not all of this information is available. You might not see that, you won't see the strat sections now. You're not going to see the sample metadata, but at least you can figure out where we've worked. And that's probably going to be your very first step. Okay, so if you go into the database, we didn't make a really nice video like Abby did. I think that we will have one with her very calming voice. So this will probably be made available as part of this best practices. But if you want to learn about where we've gone, you just go to the map that's on the public website, and up in the right-hand corner, there's this box up here, and you just toggle off everything else and just turn on the geologic sites. And then you can zoom in. Okay, so we can zoom in here and pick some sites and say, oh, I'm really curious, what's there? I want some proximal samples or whatever you're looking for.
I was going to point out the 104 on the summit of the volcano. That's kind of a red flag that those are probably default locations because we haven't, I don't think, ever landed on the summit of Shushalbin. So
yeah, anytime you see a sample that's that location, know that there's just the metadata are currently missing from the database, but it doesn't mean they don't exist, and we can probably find it. You can probably find it. Okay, so then you hover in a little bit further. So those two sample sites on the last slide, then we've kind of come in on that. And here's what you really need to know. So at this point, this is really all that you have access to is where we've been and who the principal investigator is. So in this case, Matt Loewen, and we say that's who you should contact. So that first thing on the checklist is who do I contact to figure out what samples are there? Well, now you know that samples from this location or this volcano come from this person, and you can reach out to them. And the reason we say sort of is because we can only currently enter one PI in that field. And often there are many of us in the field. And I think a few years ago, I thought, oh, let's just use Danica Blatter's name because she was with us, but in fact, she's not at AVO. And if you were to contact her, she would have no idea what you're talking about. So the sort of means, yes, we'll figure out who it is. So you might contact Matt and he'll say, no, you need to call Kristi, and we'll get there. And then if you look at this record, you can see that there's no publications, there's no links to publications. So you just know that there's a bunch of unpublished data. It looks like they've been to a lot of places. Awesome. I'm just going to reach out to that person and try to get what I need, or ask them what they have, or collaborate on a project or whatever. And then if there is a link to publications, then you can go in and start searching those data. Okay, so now that first step is like you've reached out. So you've figured out where we are, you know who to contact, and you reach out. And that's what we're really pushing as a best practice, is reach out to someone at AVO before you start a project, so that we can help you decide if that's a good idea based on the samples that are available, or the fact that maybe somebody else is working on that. There's a lot kind of behind the scenes that isn't visible to everyone. So you might say, oh, nothing's been done at this volcano, when in fact there's a ton of work done. So we're trying to make that more available so that people can see that a lot of work is happening, but it's maybe not published yet. So we're really encouraging reaching out to individuals.
And I was gonna add to that too, like, one, you might think no one's worked on an area because there's no publications, and finds out that we've had a big field project, but just haven't been published. The flip side is you might find a bunch of samples and think, wow, I can do an amazing melt inclusion study, and discover that actually all we collected was giant bombs and for whole rock analyses, because that's what we were interested in at the time. So it kind of can save you also a lot of effort on the far end if you work with people on that early on. So the geochem search, if you were following our website, it disappeared for a little while. We got a nice flashy new website, and hidden in that was certain things disappeared. Part of that was well mentioned, the API, which will be a much better search and solve a lot of frustrations, was hoping to come out quickly. But you know, we're really short staffed and things aren't probably changing anytime soon on that front. So after a while, we realized that we just need to get the old one back. So it's back. It looks like it's from the early 2000s, because it is, but it works. So we'll go through how to use that. So if you go to that search interface, you come to this little page. There's got glass and whole rock data. There's a whole lot more whole rock data in there. If a sample was collected and there was no geochemistry published on it, which is likely, it's not in here. And at that situation, that's where you reach out to Abby right now, because she can help you do that search and get that information to you from the database. We can do that internally, but Abby's kind of the point of contact for that externally. And hopefully within a few years, we have the better search that gets this all more accessible to the public. You can search for one or more samples. You can search for them by the sample ID. Looks like that's the only option on here. You can search by eruption, by year, by volcano, by reference. Lots of options in here. There could be more options in a future version. So it's functional, and it will be someday hopefully more functional. When you do a search, you've got this station ID. That's here. This is the station metadata. You've kind of already seen that on the other search. It's useful, but what you're really after if you're looking for samples is the sample metadata. So if you click on the sample ID, you get this little pop-up. If we look at that in detail, this is where you can see that this is that peat selling sample. We can see the text description there, or maybe you'll get a better hint of whether that sample is going to be useful for you or not. And then the really important thing is down here in the sample storage. So it's got whether it was a hand sample or an analytical pulp. If you don't want a bunch of powder, probably don't request the GMC barcodes for the analytical powders. But if there's a hand sample, that's probably what you're looking at. After, there also might be offcut billets, things like that. So what you're really then going into is you're going and finding this GMC barcode. If you're lucky, it'll have a weight. The vast majority of samples don't have a weight because in the effort to try to get things to the Geologic Materials Center, we skip some steps. But that's something we'll talk about in a minute, is how you can help us with that. So anyway, you copy this information and we start building a sample request spreadsheet. So we have this form that we'll distribute at the end of this workshop. Basically, just at the top, we've got a little like quick description, who you are, who's going to do the sampling. all the GMC barcode IDs. The GMC, that's all they care about. They're just looking for the boxes and they're going to pull the boxes, and then you're going to have to look for the samples. For your own sake, write the sample IDs that go with those boxes and what it is that you're looking for, and then fill in that information. And that brings us to here. So we've reached out, we've hopefully collaborated to find a project, or maybe you just want to go alone. That's not, not ideal, but it's fine. You build your sample request of what you think you want. The GMC wants to see kind of a short abstract. It doesn't need to be a big proposal, just something explaining what you're doing, why you need the samples. And you submit your samples and that abstract to the GMC. What they're going to do is they are going to bounce that to AVO. Technically the AVO SIC, but practically that's going to probably go to Michelle Coombs as the geologist, because Matt Haney doesn't care that much about this, being a geophysicist, rightfully so. And we're going to approve or not approve. Realistically, we're going to approve it. I don't think we're into not approving it, but what you might get is feedback from Michelle. She might say, hey, why don't you contact Kristi? Kristi's actually working on Acatan tephra. You should work with her on this. She might say, actually I don't think this is going to work. These samples aren't good for this. She might ask you more questions. She might help get you to kind of go back to that first step if you haven't done it. Or we'll say yes, which is basically and at that case, what we're trying to implement that's new, and we've started doing it for eruption response samples, but I think we're going to do it globally, is to have a formal sample sharing agreement that we have you sign. We're not going to police that very strictly, but it's kind of recognizing the fact that like a lot of these samples we don't own. We collect samples on national park land. That means it's the national park samples, and we are technically loaning those from the national park. So then we're also loaning them to you. So it's a bit of an acknowledgement that you get this sample. It's technically a loan, just like the Smithsonian does. We're okay with you destroying some of it to do a whole rock analysis, but we do request that all of the material and all of the products that you make with it come back for the archive for future science. And I think that gets us down to here. So let's say you're approved. That's really exciting. And that's where we say, come schedule a visit. We have in the past tried to go there for people and collect samples. Still something I think we're okay doing occasionally, especially as collaborators, but generally speaking, this is not the Smithsonian. It's not a fully curated collection where you can send in your requests and a nice box comes your way. And we don't have the staff to do that, and we're not going to have the staff to do that anytime soon. So buy a plane ticket, come on up in the winter when it's nice and snowy, and come to this old Sam's Club, which on Friday you can come visit. And there's all these giant racks of boxes. They're going to unload those for you. They're going to put them in a nice room. They might even open up the boxes for you, and you can go through and see what you find. And that brings up a phrase they have, which is nothing is guaranteed until you open the box. So you've requested a sample and you're so excited for your project, and you show up and you find out that that hand sample was actually a little tiny glass vial with like 5 things in it. So, and that comes to, we don't have the best documentation for what is exactly there. It could be a little sample, not so useful for you. It could be a ton of sample. And then just with that, be prudent when you decide what to collect. There's a general rule of thumb the Smithsonian uses, always leave 50% behind for the next project. I think that's a good rule of thumb. We are okay with sometimes going over that for good scientific purposes. But also remember, the more you analyze a sample, the more valuable that sample is going to be to future work. So really try to be careful, especially with those eruption samples. But that said, these samples are for doing science. So please try to do science with them. You're there. Record the date, record what you removed. This is where you can help us out. Write down, weigh or estimate the volume of what you take, and weigh and estimate the volume of what's left there, and write it down. And then we're going to start building in that, backfilling that database so future people can see what's actually there. Record what you're going to do with it, how much you're going to consume, destroy, or contaminate with like some nasty chemicals so nobody really wants it back. Or, you're going to say, this is how much is going to be left, or we're going to have some mounts, some polished mounts, and we can return those in 9 months. And at that point, send this all back to the GMC, telling them all this stuff, and then do your thing. Do whatever you're going to do with the samples. And then this last bit. So when you're done, I think the GMC will, especially if you mostly go through them, will bug you about returning the samples at some point. So please try to do that. It will help future people. And then share your results. We're not going to come after you for these, but we want to know what you're finding out about the samples. We'd like to be in the loop. The GMC wants you to send any published products back to them. And then also the world wants to see it. So when you're publishing your data, please follow, it's hard to not do this anymore, but, try to do it in an open way. So it can also come back to the database and populate that geochem database. And yeah, I think we're out of time, but just a quick kind of summary. So just, this is a really organized data set. It's got a lot of rich metadata for a lot of the samples, and it's really cool because it's a one-stop shop for your Aleutian Arc geochemistry whole rock sampling, which is a cool thing to have. But it's not a curated repository like the Smithsonian. It's going to take some work. It's going to be messy. It's not full service. You're going to probably have to put in some elbow work grease to get this done. And we're improving it still. So we're trying to get more of the search interface out there. Any questions?
What if like 3 people at different times kind of want to do the same thing? Is that part of what you try to pay attention to, is not people duplicate efforts, but
kind of. And so for an eruption, definitely, that's, I think, the goal of Jess running the SAC is to try to help, I would say, gatekeep, but referee that, facilitate people working together and not overlapping. And I think like Michelle, as the approver of these sample requests, might be in that feedback loop of saying like, just so you know, this other group is also doing that work. I don't know, Michelle can answer whether or not she would say no to a proposal if somebody else was doing it. Probably not. It would probably be more of a gentle nudge. It'd be more like, look at all this geography. Maybe you'd like to work on this volcano, and try to keep us playing nice with each other. Yeah.
So when you say return products, would that mean things like grain mounts and things like that?
I think that would be encouraged. Like I say, we're not the sample police. No one's gonna come knocking on your door and checking to see if you've got any grain mounts. But I think like when you're done, what are you gonna do with those grain mounts? You're gonna put them in a drawer where they're gonna collect dust and you're gonna retire and they're gonna get thrown away? Or do you want to throw them back in the box with the original sample where someone down the road might be like, oh, this is awesome. I don't have to make a mount. So I think it's just one of those, it would be nice to send them back to the collection. Yeah.
Very quick question. So if the samples are either prepared by AVO people or people coming to choose the samples, you have also facility to cut the samples, sometimes you don't need to get an entire bomb, but maybe you just a chunk.
You'll see Friday, they do have a prep lab. You might need to, when you reserve your time with the GMC, you might need to say, hey, I need access to the rock saw room. I always just bring a hammer so I can chip off a little chunk, things like that. A lot of our samples, we crush them up in the field, so they're ready to send to rock. So they'll already be in kind of quarter to dime sized pieces in the bag. So if you just need a tiny bit, it might already be that way in the bag. But yeah, there are some prep facilities there, but you might need to make arrangements in advance to use those.
Thank you.
Yep.
Just one little addition, and hi everyone. It wasn't here yesterday, but I'm glad to be here. These are AVO samples, but these are actually Alaska volcano samples. So we have had some research collaborators who have worked on Alaska volcanoes, and they say, hey, can we send our samples to the GMC? And we say, absolutely. And we help them do that. And then at the GMC, we don't care if the samples were collected by an AVO person, or basically they're Alaska volcano samples. And at the GMC, they're tagged as AVO samples. So again, it's just sort of, encouraging people, if you're retiring and you want your Alaska volcano samples to go to the GMC, that's wonderful, and we can follow that.
All right, well, thank you so much for that. That was great. If you have more questions, I'm sure that they would be happy to answer them during the break. So our next